Reflection. First, let's understand here what is reflection and how do we apply it in coordinate geometry. I use the word here, coordinate geometry. So what is coordinate geometry? It's a branch of geometry in which two numbers called coordinates are used to locate the position of a point in a plane. So let's see. For example, there is a plane. You can see this is the plane. Starting from here, this is the plane that we have here. So what we have done, if I move from left to right, then this is the line I have drawn for it. If I move from bottom to up, I have drawn another line here. And I have calibrated both of these. You can see it is calibrated. Since that is from, okay, a point we can go left, from a point we can go right, from a point we can go up, from a point we can go down. So this is why we mentioned that point here, the origin is this one. So point where we start measuring from, we started from where? The middle one here. So you can see there is a plane, and in the plane this is the starting point. Say I would say this is the entire thing starts from this point called origin. Let's say if I have a point, if we move right from it, if it is this, so we have only moved towards the right. Have we moved towards the upward side? The answer is no, we have not moved, right? If I move here, then have I moved from, we have moved from that point of origin to upward point. We call this point where we start from as an origin point. So upward. Have we moved to the right side or left side? The answer is no, only upward. Is that okay? So when we move from left to right, then we say that we have moved only, okay, this is the x direction, this is the y direction. So we have moved in only x direction, right? How much? 3. Have I moved in upward direction? No, at this point. So it's no, no means 0. Here, have I moved in upward, have I moved in the right direction or left direction in x direction? Answer is no. Have I moved in upward direction towards y? Yes. So how much? 3. So this is how we are able to have a point located on it. Now comes here, when we have to, this is the point on only left, right or bottom and top. Fine, from the origin. Now what about this? If it is here, so to reach this point, say if it is point P, to reach this point, what do we have to do? We have to first move one here, okay, and then you have to go up. So we have moved both. How much we do move from left to right? That is 4. How much did we move from say this origin to upward direction? 2. So this is it. So how do we locate that point here? How do we locate the point? So we can locate it only from the origin. With respect to origin, it is 4, 2. Are you getting the point? So this two mutually perpendicular lines on the intersecting line each other at their zeros are called rectangular axis. You know about this is the axis we are talking about, and the coordinate axis and the axis of reference we also call it as. It has got different name: rectangular axis, coordinate axis, or axis of reference, right? And this is the number line you can see, right? One number line from left to right, another number line perpendicular to it, and this is called coordinate axis. I think you're aware of it, so I didn't need to explain those again. Coordinate, the one which we have used, the position of a point in the plane is expressed by a pair of two numbers, one concerning x-axis, another concerning y-axis. We call this is coordinate. So this 4 and 2 are coordinates here. Is that okay? For this it would be 3 and 0 is a coordinate, and here it for this would be 0 and 3. These are coordinates, the pair of numbers, right? The first one is called ordinate. What do we call it as? Sorry, first x is called abscissa. X, right? X is called abscissa, right? X coordinate is called abscissa, and the y coordinate is called ordinate here. So in this case, this is abscissa. What is it? Abscissa. Fine. And and the other one is called ordinate. Fine, I think you're clear with that. Okay, the x coordinate is called abscissa, the y coordinate is called ordinate. Simple. So this is abscissa and this is ordinate. You can see this is abscissa and this is the ordinate here. Okay, fine. So I think you have understood this. This is what you must have done in 9th grade also. Now again here, now comes the word reflection. Before we start reflection, let's understand a reflection in a mirror. If you have a mirror, for example, there is a mirror like this. If this is a mirror here, and one of this side is polished, this side is polished, okay, this side is polished, the left side. Fine. Then you have an object here, something is lying on it at this place. You will find the image is formed on this in the mirror there. Where is it formed? Exactly behind it here, which means whatever the distance that we have it from the mirror, at the same distance is the image formed. So if you put the coordinate value here in it, if this is 0, if this is a mirror and this is 0, and this is 1, then will it not be -1? Got the point? So it is formed behind the mirror, where image is formed behind the mirror, and you understand why it is so. Clear? So let's understand the reflection now in it. When an object is placed before a plane mirror, the image formed is at the same distance behind the mirror as the object is in front of it. Considering that this is the mirror, an object is kept here, so the distance from the mirror to this particular object, image will be formed here. So if the object has a coordinate as x comma y, so the image will be have a coordinate, say maybe x1, x2 or x dash or y dash in it. And if the object is p, the image is p dash. Okay, so therefore to find the image of the image of a point p in the line AB, consider AB as the plane mirror and point P in the object. Now find P dash on the other side of AB such that P dash is at the same distance from AB here. Okay, so this is called image. P dash is a image point, and AB, okay, of in the line AB and AB, which is also perpendicular bisector of this one. Okay, we know that this is the perpendicular bisector. When we talk about perpendicular bisector, what is it? It is basically is a point, it's a line which is bisecting, means dividing this AB into two equal parts, and right, this is perpendicular as well. So well, this is just okay, we would just need to understand where the image is formed. Obviously it is a perpendicular bisector on which the image is formed. So how do we transformation, this transformation means when the image, the reflection has happened, we write the coordinate of the P dash. Okay, P is the object, P dash is the image. So when we write this, we call the transformation which maps a point P to P dash is called reflection. That transformation that we write it as is called reflection. So basically it's a reflection in normal language, same thing, but this transformation of an image formation of the object in front of a mirror, okay, which is the image is from behind the mirror, this transformation which P has become what, P dash as an image, and when we write the coordinate of P dash according to the P that we have is called reflection. We don't need the definition for all of those, but you must understand what is it. The reflection can be denoted in several ways, but it will be denoted by M. You can see what is the letter M, I here, right? Fine, or M1 or maybe anything, MX, MY, MO. M stands for reflection, and L, okay, it is ML. L is the line or point in which the reflection takes place. What is this? L. Understood the point here? Now, M is nothing but the reflection, and L is the line or a point in which the reflection takes place. MX represent the reflection in x-axis, MY represents the reflection in y-axis, M0 or MO the reflection in the origin here. See what happens. You take it the other way around. When I say MX means reflection in x-axis means what? In that case x-axis is a mirror. X-axis is a mirror. If the reflection takes in y-axis, then y-axis is a mirror. If the reflection takes in origin, then origin is the mirror in it. Okay, how that? For example, if you say there is an object kept over here, where is the object? The object is at P here. Okay, the object is at P. Fine. So where is the object? Here. Where will the image be formed? Image will be formed exactly behind that, here only. Fine. So if this is P, this will become P dash. Now, but which is the mirror acting in it? This x-axis is acting as a mirror, so we can write mx. So when I mx means it is x-axis is a mirror. What is it? Is a mirror. When I say my, then y-axis is the mirror, right? Got the point here? Say if it is here, the image will be formed exactly where? This point. So if this will be P dash, right? Taking P double dash. Okay, simply dash here because you will get confused. The double dash is something else. Now, so this is when y-axis is a mirror here. Now, if this acts as a mirror, the origin, how can the origin act as a mirror? You draw a line perpendicular, sorry, at a 45 degree here, right? 45 this and 45 this here, 90. Okay, anyway, forget about that degree part. If you draw a line for 45 degree, this will behave as a mirror. So if you have an object here where the image will be formed, okay, this is 4, it will come here, and this is 3, it will be image will be formed here. P dash. Is it clear? Fine. Then which is the mirror in it? This mirror is called mirror of origin. What is that? Mirror origin here. Clear? So what is that? This is the mirror, and what is that? Origin is the mirror. I hope you have understood what is the mirror when we talk about either x-axis can be mirror, or y-axis can be mirror, or the origin can be mirror. Now when we have the object here, this is the way that we can draw the mirror, and when the object is the other way around, for example, the object is not there, object is say here, object is here, then this is the way we can be drawing. But there's no need to draw that, just to let you know this is the point of, just to let you know that this is a mirror, because we have a say perception that the mirror is always a straight line like that. Okay, and since it is a point, it becomes difficult, but it's basically the point which is helping it what to reflect. So basically it's reflecting from here, not from this line here. Okay, just to have a perception that yes, we have a perception that mirror has to be a plane. That's the reason we drew this. Okay, next is reflection. When an object is placed before a plane mirror, the image formed is at the same distance behind the mirror. We talked about it. We have already done this. Now reflection in y is equal to 0. What is a line which is y equal to 0? If you take this particular, okay, this thing, just give me 1 second here. I will take it. Reflection in y is equal to 0. So which is the line y is equal to 0? So when I say y is equal to 0, in the coordinate you have to make a table to understand that what is y equal to 0. So say this is x, this is y, right? You make table. So y is 0 all the time. Okay, when x is 1, y is 0. When x is minus 1, y is 0. When x is 2, y is 0. When x is minus 2, y is 0. So let's draw it on the number line on the graph here. Cartesian plane we call it as. So x is 0, y is 0. Where is y 0? This one. So x is 1. Where is x is 1? X is 1 and y is 0. The same point. X is minus 1, y is 0. X is 2, y is 0. X is minus 2, y is 0. So where are the points? These are the points. You keep on moving, it is endlessly, you join all the points. So if you join all the points, it becomes what? Y is equal to 0. And you extend it because it's not ending over there only. Ending only there. So when I say y is equal to 0, then what is that? It is x-axis only. What is it? X-axis. And vice versa. When I say x is 0, it will be y-axis. Remember this. Clear? So reflection in y is equal to 0 means reflection in x-axis. Simple. So which means you have a, this is the mirror here. Why is it mirror? Because y, this is all the line, this entire line is y is equal to 0. This is y is equal to 0. So when you reflect, if you keep the object here, so where the, if the distance is a y, where is the image formed? Here, right? If the coordinate is, say this is the coordinate x here and this is y here, right? So what is the coordinate of this particular point? Px comma y. So what has changed? Y has changed in it. Can you see that? Y has become negative, but x is the same in it. Okay, so whenever you reflect it through x-axis, as a x-axis being a mirror, then the coordinate of y will become opposite. Is it clear? So when it is reflecting through x-axis, coordinate of y will become what? Negative, or opposite we can say. If it is negative, it will become positive. If it is a positive, it will become negative. Is that clear? Now so see, in this case here, if you have a point 2 comma 3 and you reflect it through x-axis, remember this only will change, y x will not change, so it become 2 comma minus 3, right? Is that okay? If you reflect 2 comma minus 3 in x-axis, again this is minus, it will become plus here. Got the point here? So either way, now got the point here. Next is when x is 0. I said when x is 0, then it is y-axis. You are reflecting through y-axis, and what is the y-axis? Let the point be P here. What is the coordinate? X comma y. Now we know that if it goes behind, only x is changing, it is y is not changing. Y is the same in it, right? So has it not become minus x? X was plus, it become minus here. So in the line when x is 0, it means y-axis is a mirror. What is a mirror? Y-axis. And when a y-axis is a mirror, then you know the reflection, the coordinate would be like, say if there is a point and which has a coordinate 2 comma 3, means 2 is abscissa and 3 is ordinate x, and this is y. So what change in it? It will x change, so it will become minus 2 and 3. If it is 2 minus 3, it will become minus 2 minus 3. Is that getting the point here? So that is, and this is how we write it. Okay, this is a shorter way of writing, right? My means y axis is a mirror, and you're reflecting through 2 comma 3, it will become, give you what? Minus 2 comma 3. This is the abbreviated form of writing it, shorter way that we can write the reflection as such. If it is MO, then it is reflecting through origin. Remember that? I think next part is there. So if you're reflecting through origin, this is the mirror, right? Remember, this is the mirror here. So where is the image form? So if it x is there, you can see it, x has become negative this side, y is also become negative this side, so both will become negative negative. For example, here when you reflect through origin, if it is minus 2 minus 3, it will become what? 2 and 3. Or if it is 2 and 3, it will become minus 2 and minus 3. And this is the way we write it in shorter form. That is, a mirror is the reflection through the mirror or origin, right? 2 comma 3, it become minus 2 comma 3. And if it is minus, 2 comma minus 3, it will become minus 2 comma plus 3. Okay, is it okay? So you must understand that, yes, when you're reflecting, where is the image form, and accordingly you have to write the coordinate. So this is the reflection through all those different kinds of mirrors that we can call it as, that is reflection through x-axis or y-axis or through origin. We will have some examples coming up after this video. You can watch that.